Princess Sumaya University for Technology, Department of Electrical Engineering, Microwave Engineering course, Spring of 2018, video project by Haneen Mahmoud, Rami Sarhan, and Roda Dabit. Hello and welcome. This video shows how to design a microwave transistor amplifier with minimum noise figure.
Okay, here we want to design a microwave amplifier using a BGT with a minimum noise figure and a maximum available power gain. The BGT that is used in our design has the following as parameter and minimum noise figure. Here we use a calculator that is designed by our student at PSUT University. We write the BGT's parameters. Since a minimum noise figure and maximum power gain cannot be obtained simultaneously, constant noise figure circles together with constant available power gain circles can be drawn on a Smith chart, and source reflection coefficients can be selected that compromise between the noise figure and gain performance. So our goal is to design a matching circuit at the input port to achieve minimum noise figure and maximum power gain. First, we find available power gain circles. Here we have a maximum available gain that is 14.7 dB, and it appears as a point on a Smith chart. So we find available gain that is below the maximum available power gain by 1 dB, and so on, and take their circles, radius, and centers to draw it on a Smith chart. Hence, we take a group of available gain values that is needed to obtain optimum noise performance. After that, we find noise figure circles. We have a minimum noise figure with 2.5 dB, so that we find noise figure circles that is higher than 2.5 dB by 0.1 dB, and draw them on a Smith chart in order to obtain optimum noise performance. So we take a group of noise figure circles with the available power gain circles and write them on the table in order to draw them on a Smith chart. Here we find the scale of our Smith chart that is needed in order to draw the noise figure circles and available power gain circles. And it's 8.1 centimeter. Here we made a table for all the radius and centers of available power gain circles and noise figure circles and phi scale in order to draw them on a Smith chart. Okay, let's get started to draw the available power gain circles on the Smith chart. Our BGT transistor operates at frequency 4 GHz. For this transistor, it follows that K is higher than 1 and delta is lower than 1. Therefore, the transistor is unconditionally stable at 4 GHz. So, here we draw the available gain circles in the gamma S plane. Observe that since the transistor is unconditionally stable, all the available gain circles are completely inside the Smith chart. After drawing all the available power gain circles, we move to draw the noise figure circles from 2.5 to 3 dB. Here we have a multi-intersection between available power gain circles and noise figure circles, but we are looking to a minimum noise figure that intersects the maximum available power gain. Here we will take a noise figure circle with 2.6 dB that intersects the available power gain with 11.7 dB. We have two intersection points and both of them satisfy voltage standing wave ratio that is lower than 5. So we can take one of these 2 points in order to find a matching circuit at the input port to satisfy noise figure with 2.6 dB and available power gain with 11.7 dB. Therefore, a sacrifice in gain was needed to obtain optimum noise performance. The load reflection coefficient is selected to provide a maximum power transfer to the load, that is, load reflection coefficient equal conjugate of output reflection coefficient. So we can design matching circuit at the output port in order to provide a maximum power transfer to the load. Thanks for watching and I hope you have a good day. If you have any question, please don't hesitate to write a comment below.